Hello everyone, welcome to this project called hate speech classification. So here we'll be applying NLP technique to solve this problem. So now you can ask me why I will be applying NLP technique. So here by reading this project title, I think you got it. It is going to be like the analysis we will be doing, okay, it is on top of the text data. So that's why actually we'll be applying NLP technique. And here what we are gonna do, we're gonna build one like you can say system. It would be able to classify whether a tweet is hate speech or not hate speech, okay? Because nowadays if you see in the social media, there would be a lots of you can say messages, tweets, okay, post. So what kinds of post, what kinds of tweet it is, okay? So basically here we'll be using Twitter data, okay, like in this project. But you can consider any kinds of data, any kinds of social media data. It might be Facebook, it might be you can say LinkedIn, okay, anything actually you can consider. But in this project I'll be using Twitter dataset, okay, that means tweet dataset. So here we'll be trying to classify whether a tweet is hate speech or not hate speech, okay? So this is the actually project introduction. I think you got it, okay? So in this video actually I'll be giving you the project overview, like what are the things actually we're gonna do throughout this entire series of our project, okay? So guys, first of all, I will give the introduction, like what is hate speech classification and all about, okay? Then we'll be understanding the problem statement, like before implementing any solutions, okay? You need to familiar with the problem statement first of all. Then once we have understand the problem, then we'll be starting with the solutions, okay? I have proposed. So what is the solutions like I have created, okay, to like you can say prevent this kinds of problem, okay? Then once it is done, then I'll start discussing about the code, okay? So we'll be writing the code, and I will like discuss each and everything, like how you need to ingest the data, okay, how you need to transform the data, how you need to train the model, everything I'll be discussing about. Then once it is done, we'll be also deploying the project. So once you have done the implementation, so we also need to deploy the project, okay? Then at the end, I will like conclude the project, okay, with some task and assignment so that you can perform this one. Then understand problem, we'll be discussing about like problem description, then understand the application scope, okay, like where we can use this application. Then I will also discuss about some existing solution, okay? So whether some existing solutions are available or not. If they're available, okay, what is the like you can say difference, okay, without solutions, okay, we'll be discussing this thing. And we'll be also discussing about like the solutions. So inside solutions actually we'll be understanding the solution description. Then we'll be doing some experiment, okay, with the notebook. So before implementing the actual code, we'll be doing some experiment. Then I will show you some of the flowcharts and architecture diagram, okay, of our entire project, so that it will be very much clear before implementing, okay? Then I will also discuss about the cost involvement, okay, in this project. Then once it is done, then I'll start with the code understanding part. So here I will give you the structure overview, okay, like how you need to create the folder structure and all about, okay. Then I'll discuss all the components like data ingestion, data transformation, model training, okay, model push and model prediction, each and everything. Then I'll also tell you what is configuration, what is constant, what is entity, what is exception, okay, everything I will be discussing about. Then once it is done, then we'll be I'm discussing about the deployment, okay, we'll be deploying the project. Then at the last, I will give you some of the assignments, okay, and we'll conclude the project, okay. So yes guys, this was the project overview. I think you got it, okay. So throughout this entire series, we'll be discussing these are the components, okay. So here, if you see, hate speech classification is the process of identifying and categorizing speech or language that may be considered offensive, harmful, and promoting violence towards individuals or group based, okay. So this task is usually performed by machine learning model, okay, that has been trained on annotated data sets to recognize patterns in a language and determine the level of the hate speech presence in a given piece of text, okay. So basically what I'm trying to say here, this hate speech classification actually tries to, you can say, classify whether a tweet or whether a message or anything, okay, like a piece of text is like you can say a hate speech or not hate speech, okay. So and how actually we solve this kinds of problem, we trained one machine learning model, okay, on top of like one, you can say one big annotated data, so that actually it can get the pattern like how to detect these kinds of offensive text, okay. Then actually it like you can say classify these kinds of hate speech, okay. So yes guys, this is all about like what is hate speech classification and all about, okay. I think you got it. So here actually you can consider this hate speech classification anywhere, like where you have your social data or social media platform, okay, like Facebook, you can say, then Twitter is there, then LinkedIn is there, okay, anything like you can consider, but in this project we'll be using Twitter, okay. So here if you see in the internet age, where the information flows has grown rapidly, there is an increase in digital communication, okay. So whenever this kinds of digital communication is increasing more, like people are being used this Facebook, Twitter, okay, then Snapchat, then WhatsApp, YouTube, okay, so Instagram, so like there are so many of like social media platform they're using broadly, okay, these kinds of application. So what is happening actually, okay, like they're trying to communicate with each other. So like sometimes actually they send some kinds of, you can say, hate speech message, or you can say offensive message. So what happened actually, so like opposite person might not get this kinds of you can say communication in a good way, okay. So that's why actually it's required to detect these kinds of, you can say, offensive message, or classify these kinds of offensive message, so that actually we can prevent, okay, like the violation. So this is the actually problem statement actually I'm trying to say here, okay. So that's why actually we are considering the Twitter, you can say, data set, but here you can use any kinds of data set like Facebook data set or Instagram data set. You will get this kinds of data set from the internet itself. But in this project, my objective is to to teach you like how you can approach this kinds of problem statement, okay, what would be the process. So I will be like solving on top of Twitter data, but you can use any kinds of data set, okay, if you learn the process, okay. So yes guys, I think you got it, the problem statement we're gonna solve here, okay. So see guys, if you can integrate this kinds of application, okay, in the, you can say, Facebook or Twitter, or you can say Messenger, okay, then your YouTube, okay. So see, nowadays actually like this kinds of company actually already have implemented this kinds of system. So actually if you send any like hate speech, or if you send any offensive message, it will be able to detect, okay, and it will block your account, okay. If it is like very offensive, it will block your account for some days, okay, and they will give some warning, so you don't have you can't send these kinds of messages, okay. So this kinds of application is already available, okay, if I talk about so I just wanted to like let you know like why we can use these kinds of application, okay, what is the scope of this application, okay. Now I think you got it. So if you just try out, okay, if you just see like in your Facebook, or like you can say Twitter or Instagram, if you just comment any offensive message to anyone, you will see like they will give you some of the warning, okay. So here basically we have implemented one machine learning models, okay. So here actually we implemented one LSTM based architecture, okay. Then we trained this model on top of one, you can say, big annotated data set, okay. Then we created this kinds of system, okay. So instead of like telling you, let me show you the demo of this application, like how it will work, okay. So for that I will open my application and I will show you. So guys, this is my project folder. So this project actually I already have implemented. So here first of all let me execute and like show you like how it will work. So let me run my application. So I'll just write python app.py. So app.py is my endpoint. So it will actually launch my you can say Flask, so it will actually launch my FastAPI server, okay. So here actually I'm using FastAPI to create this kinds of web application. Now guys, see, our application is running on this localhost port number 8080. So I'll just come here, and here I will just search localhost port number 8080, okay. If you search it, so you will get this kinds of page, okay. So here you have two route, one is like training route and one is like prediction route. So if you just click on training route, okay, try it out, and if you just click on execute, so what it will do, it will start the training, okay. So it will start all the training pipeline automatically, so you don't have to do anything. I already configured all the training pipeline. So first of all what it will do, it will get the data from the, you can say, GCP cloud, okay. So GCP cloud actually I'm using this you can say storage service. So there actually I kept my data. So it will like it is similar to your Amazon S3 bucket, okay. So GCP has this kinds of bucket also. So I kept my data there. So it will get the data from this GCP bucket, okay. Then after that it will apply its transformation, validation, okay. Then model training, model pusher. So model pusher means suppose after training your model would be pushed to the GCP cloud again, okay, to the bucket itself. So that's actually it will work the entire training pipeline. So here I'm not going to show you the training pipeline because it will take time. So instead of what I will do, I will show you the prediction pipeline. So I'll click on prediction. So here I just need to provide any text. First of all I click on try out, okay. Then here you just need to provide some of the text. So let me open. So I have some data to, like I have some tweets. So what I will do, I will first of all copy this tweets, okay, and I will give it there. So let me see whether it is able to detect or not. So by reading this tweet, actually you can see uh, it should be like, you can say, head speech. Like if you see, there is a like there are some words actually, it's like offensive word. So let me see like whether my system is able to detect or not. So I'll paste here and then I will execute. So guys, as you can see, it has done the prediction, but unfortunately it is giving no hit because because I trained this model like very less epochs, that's why it's giving the wrong prediction. But the model I trained with higher epochs, okay, I think this model is not present in my GCP. Okay, I need to check. I think you got it. Like I just wanted to show you like how your application will work. Okay, so basically if you train this model around 50 epochs, okay, 50 to 100 epochs, it will give you like very good prediction. Okay, so if you just try out any text, so it will give you the responses, okay, like that. So here I'm not considering the UI part. Okay, UI you can add if you know HTML and CSS. So that's why I'm using FastAPI. FastAPI already provides these kinds of UI. Okay, so yes guys, this is all about my project demo. I think you got it. So if you just search head speech tweets dataset, you will get a lots of link. So this dataset is already available inside Kaggle. If you see, if you just open this Kaggle link, so here you will get like a lots of data set, okay, related this head speech, okay, like Twitter head speech. So you can either download from here, either what I will do, I will share my data set with you, okay, you can use my data set. Okay, so there actually I'm using two kinds of you can say CSV file. One is like one is like imbalance, okay, like in one CSV like there are like lots of imbalanced data set, and another like I'm using it has the raw data. So what I'm doing, I'm combining both you can say CSV file, and I'm trying to handle this kinds of you can say imbalance. Okay, so that actually I can show you like if you have imbalance data set, how you can also manage this kinds of problem. Okay, but if you don't want this kinds of imbalance data set, you can download this data set and you can use it. Okay, so yes guys, this was a quick video. I just wanted to let you know like where you can get this kinds of data set. Even not in Kaggle, there are many websites you can get this kinds of data set. Okay, so as I've already prepared one notebook here, see guys, why this notebook experiment is required. First of all, let me tell you, suppose whenever you have selected any project, okay, and you want to implement that project, so before implementing the modular coding, before implementing the actual code, just try to do some experiment on the notebook side, okay, so that actually you can get the idea like what are the things actually you need to apply. Okay, and it is like very much I mean see clear to see like what are the things that are happening. Okay, what you need to do here, so everything actually you can do here. And whenever you realize everything is working fine, then try to pick that code and try to convert it to modular coding. Okay, so I like do in that way because it gives me like more productivity to write the code. Okay, so I will also suggest you just also try to follow the same approach. Okay, so guys, here if you see, I have already prepared one notebook and I already did some analysis here. Okay, and it was working fine for me. So I'll just give you the high level overview, what are the things actually I have done. Okay, and the same thing actually we'll be implementing throughout our modular coding. So, but before that, let me show you the data. So as I told you, I will be using two CSV files. One is like imbalanced underscore data.csv, and one is like raw underscore data.csv. Okay, why I'll be using this one? Because let me show you. So first of all, here if you see, I'm importing some of the necessary libraries. Okay, so as I told you, I'll be using LSTM. Okay, LSTM architecture. So that's why I'm using Keras, TensorFlow Keras. So here actually you need to install TensorFlow 2.0. Okay, and you need, these are the like you can say necessary libraries. Okay, you need to import. And here if you see, I'm reading my data. So first of all, I'm reading my imbalance data. So here if you see, this is my imbalance data I'm reading. And if I do like count plot on top of that, okay, so here if you see, the label is imbalanced here. So 0 level is like more frequent than your 1 level. Okay, like this data set is imbalanced. Okay, now how we can like prevent this kinds of imbalance problem? So what I did, I again used another dataset called labeled underscore data.csv. Okay, so here actually it has three classes. If I show you here, so first of all, here I'm dropping like unnecessary column. These are the column I don't need, and I'm only keeping this tweet and classes. Okay, now if I plot this class here, if you see, it has three classes. Okay, but here if I show you, here my one class was like missing. Okay, like see, it is like, so here if you see, it is less than your 0. Okay, so that's why what I need to do, I need to pick this one class. Okay, so what I need to do, I need to just pick this one class from this data set. That's it. Okay, so somehow I just need to take this one class from this this table. Okay, and I need to add this class to my previous one. Okay, that means this table. Okay, so that is what I am doing here. So here if you see this code actually performing that thing, and after that here if I show you, I'm creating one like raw data frame, okay, like final data frame. And now if I plot it, okay, now if I plot it, now if you see we have somehow like you can say solve these kinds of imbalance problem, okay, from our data set. Now here if you see, it is almost same. Again if you see, this one is like less, but at least it will do our job. Okay, now here I'm defining one data cleaning function. Okay, this like you can say function will do some cleaning operation, like if it is suppose if there is any HTML tags and any links, okay, it will try to remove. Okay, these are the thing. Suppose if you see, these are the unnecessary information, although these are emojis. Also you can handle these other emojis, you can also delete these are the emojis. Okay, it is not needed. Now after that, I'm doing the trend test split of my data. Okay, and here I'm initializing my tokenizer. Okay, and after initializing my tokenizer, here I'm creating the model architectures. So here if you see, I'm implementing one LSTM architecture. Okay, and after that I'm training my model. Okay, this is my like model training. Then after that, here if you see, I'm saving the model, and also I'm saving my tokenizer. Okay, and after that again I'm like preparing this clean you can say text, because whenever you are trying to do the prediction, you also need to apply these are the technique. Okay, so this is for the prediction code. Now if you just pass human are idiots, now here if you see, this is a no hits. Okay, so that's actually I have implemented this entire like you can say system. Okay, see, this is like very simple project. If you see the notebook, it will look like very simple. Okay, but the way we'll be organizing this entire project, okay, it would be like totally amazing. So whenever you are trying to create any project, just try to follow the same structure. Okay, so yes guys, I think you got it, the overview of this notebook, like what are the things actually we need to do here. So from our next video itself, actually we'll be starting with the implementation, okay, of this entire project flowchart. So by seeing this flowchart, actually we'll be implementing our like project folder structure. Okay, so this is the flowchart actually I created for my previous project, but I will be using the same format, because I always try to follow the same you can say structure to create any project. Okay, and I will also suggest you to follow the same structure. Okay, because if you follow this structure, so you can organize your code in a good way. So what we are gonna do, we are gonna create one root folder. So here it is clothing apparel detection, but we'll be creating something called head. Okay, inside head actually we'll be creating a subfolder called components. Inside components, we'll be writing all of our components like data ingestion, data transformation. Okay, then model evaluation, model trainer, model pusher, everything. Then we all also write our this configuration. Okay, inside configuration it was S3 sensor, but here we'll be write our like GCP sensor. Okay, so that's actually we'll be creating constant, entity, exception, logger, pipeline, utils, and ML folder. Okay, so these are the folder actually we'll be creating folders and file, and I will explain each and everything, each and every components whenever I will be writing the code. Okay, so what I will do, let's create this folder structure quickly. Okay, then I will show you. So guys, here I have created one like folder, project folder called head speech. Inside that I will be creating all the folder structure. So guys, here if you see, I have created the folder structure. So this is the folder structure, guys. So if I open this one, so here if you see, I've created one root folder called head. Inside that I've created all the subfolder. Okay, all the subfolder, and inside that I've created all the components. Okay, so you just check it out. Okay, you will get it like what are the folders I've created, and additionally I've created some of the extra files like this requirement.txt docker file. Okay, because these are the things we needed. Okay, so yes guys, this is the folder structure, and I will share this code with you. You can get this from your resources section. Okay, so now what I will do, I will commit this changes, okay, inside my GitHub, because it's a good practice whenever you are trying to implement any project. Always try to use your GitHub, okay, to commit your code. So for that, what I will do, I will open my GitHub. So here I will click on the new repository, because I need to create one new repository. So here actually I will be creating one new repository. Okay, so I will name it as hate speech classification. Then I will make it as private. Okay, as of now. Then also add the readme file, and I will also add git ignore of Python, and also I will add license. Let's take MIT license. Okay, now let's create the repository. Okay, now just click on the code, copy the link, open up your project folder. Okay, so this is the project folder. So here I will open my terminal. So I think I already opened my terminal. So here what I will do, I will just write git clone. I will paste this link. So it will clone that repository here. Okay, so after cloning I will open this one, and here I will cut everything. Okay, just press Ctrl X. Or what you can do, if you don't see this .git file, just try to activate your hidden item. Okay, because this .git file is needed. Okay, now just come back and paste it here. Okay, in your project folder. Now delete this folder. Okay, now let's open my VS Code. Now if you just click on source control, now you see these are the changes should be committed. Okay, so now what I need to do, I will open my terminal, and I'll just write git add space dot, then let's do commit, git commit hyphen m, let's give folder structure edit. Okay, then I will just write git push origin main, because this is my main branch. Okay, now it will commit the code, it will upload every like you can say folders and files inside your GitHub. So guys, if you see it's done. Now if I open my GitHub, now let's refresh here. Okay, now see everything has been committed. Okay, so guys, we have successfully created our folder structure. So and here first of all I will create one virtual environment. Okay, so to create the environment, just write conda create hyphen n, and just provide the environment name. So I will just give head, then try to mention the Python version you want. So I will use Python 3.8, and I will just give hyphen y. Okay, so this is the command you just need to run. Now let's execute. So guys, as you can see, environment creation is done. Now I need to activate. So this is the command conda activate head. So just let's write conda activate head. Okay, now here I have created successfully the environment. Now head active has been activated. Okay, now here I need to provide all the requirements. Okay, needed for this project. So guys, these are the requirements are needed. Okay, to execute this project. So here I'm using TensorFlow 2.9.2, then C1, Matplotlib, scikit-learn. Okay, then Google Cloud Storage, because this package is needed to access your GCP. Okay, then FastAPI. These are the NumPy. Okay, these are the thing are needed. Now what I need to do, I also need to create this head as my local package, because here I will be importing like from head. Okay, dot components dot data ingestion. Okay, if you want to import like that, if you want to like import anything from the file itself. Okay, so here you just need to install it as a local package. So for that I will also write this setup.py. So guys, inside setup.py you just need to mention these are the code. So it will basically what it will do, it will just look for this constructor file, this underscore init.py. Okay, this constructor file. Whenever this constructor file are present, it will consider that folder as my local package. Okay, it will automatically install. But to install this one, you just need to add inside requirement.txt hyphen e space dot. Okay, this line you just need to add. So it will basically look for your setup.py and it will install. Okay, now let's install. So for that I'll just write pip install hyphen r requirement.txt. Okay, so it will take some time to install. Okay, so once it is done I will come back. So guys, as you can see, installation is successfully done. So if you are not getting any error, that means you have successfully installed everything. Okay, I believe you won't be getting any error. Okay, because everything is running fine for me. Because as I told you, I will be reading the data from my GCP. Okay, GCP cloud. That means we will be using GCP bucket. Okay, and we'll also push our model after training to the GCP cloud platform. Okay, so for that actually we need to set up the GCP first of all. So in this video I'll tell you like how you can set up this one. It is already set up in my system. Okay, so first of all what you need to do, first of all you need some code. Okay, like to access GCP console. Okay, from the Python itself. So for that just open your head folder. So there I have created one folder called configuration. Okay, So inside configuration, I have created one file called G Cloud Sensor. So this G Cloud Sensor actually will be using to download any data set, okay, to download something or to push something from our local directory. Okay, so here I have prepared two methods. So let me show you. So guys, this is one G Cloud Sensor class I have prepared. Inside that I have prepared two method like since folder to G Cloud, okay, and a since folder from G Cloud. Okay, so this method will be using to download the dataset in our local directory, and this method will be using to push something from our local directory to G Cloud. Okay, so these two method you need. So you can use this code, okay, in your every project, so you don't have to change anything here. Okay, so now what you need to do, you need one CLI tool called like G Cloud CLI. Okay, so for this you can come to Google and search about like install G Cloud SDK. Okay, so you will get the link to download this SDK. Okay, so it is available for every operating system. Okay, so you can download. So what I will do, if you are using Windows, so I already have the link, so I will share the link with you. So let me show the link. So guys, this is the link. You just need to click. So here, if you just execute this link, it will automatically start downloading this. So it will automatically start downloading this Z Cloud. Okay, so this is the exe like file. Okay, so what I will do, I will give this link, okay, in the readme file, so that actually you can use it. Okay, so I'll just write G Cloud. Okay, CLI. So here I'm pasting the link. So here you can get the link from here. Okay, so just copy the link and like go to Google and paste it and execute. So it will download this exe file. So let me show you the exe file again. If I go to my download, so this is the exe file. Okay, so now what you need to do, you just need to double click on this SDK. Okay, so it will you can say tell you to do the next. Okay, the way you install any software, you just need to install this Google SDK. Okay, so after you have done the installation, you just need to open up your command prompt. Okay, you just need to open up your command prompt, and here you just need to write G Cloud. Okay, G Cloud init. Okay, so this is the command you just need to run. So if you run this command and if you execute, okay, so it will be redirecting to the your browser. Okay, and here it will tell to logging with your GCP account. Okay, so here I'm expecting you have the GCP account. Okay, if you don't have GCP account, you can create one GCP account. It is so for first time you will get $300 credits. Okay, like you need to add your card for sure, but at least try to create the GCP. Okay, then actually you just need to log in with your that account. So there actually you need to select that account. Okay, the account actually you have already created the GCP account. Okay, so just try to log in with your like you can say credential. Okay, then what it will do, it will ask for the you can say I'm project name. Okay, so here I have already open like logged in with my here if you see, I have already logged in with my GCP console. So this is my GCP console. Okay, if you're logging with your GCP console, you will see the window like that. So here actually you will have a lots of projects if you have created a lots of projects. So for me, I have a lots of project here. So here I have kept my data inside my project neuron. Okay, project neuron project. So you just need to give that like you can say project name. Okay, in the terminal. Then you need to press enter again. So it will ask for the region. Okay, so region you need to select. So for me it is Mumbai region. Okay, so I have already selected. So with respect to your configuration, you just need to select the terminal, select in the terminal. Okay, and just execute. It will be automatically configured. Okay, so after that just come here, and here if I show you G Cloud, just click on G Cloud. Okay, so here this is the actually buckets. Okay, so these are the buckets are available. So now here if you want to create any bucket, so what you can do, just click on create. Okay, just give any bucket name. Let's give test uh demo buck. Okay, it should be unique name. Okay, then what you can do, just click on create. Okay, see you have successfully created the bucket. So now here you just need to upload your data. Okay, so let me show you how you can upload your data. So guys, this is my data.zip file. Okay, so here I will just drag and drop. Okay, So if you just drag and drop, it will start uploading the data. I will also share this data with you, so you don't have to worry. See, I have uploaded, okay? But for me, I have already prepared one bucket for my projects, which is nothing but here, hate speech, okay? So this is my bucket name. And inside that, actually, I have kept my data, okay? So guys, that's actually you just need to upload your data after doing the configuration of your GCP CLI, okay? Make sure everything is fine, okay? From your side, you are like not having any error, okay? You will get a lots of tutorial like how to set up this gcloud CLI, okay? So by seeing the tutorial itself, you can also configure, okay? First of all, let me show you the data ingestion flow chart, okay? So I think I already discussed, but let me tell you again. So in data ingestion, components, okay, you will have some of the configuration like bucket name. Like see, why I need to pass the bucket name, because okay, in the bucket itself I kept my data, okay? So if I pass my bucket name, so my Python code automatically will access that bucket, okay, and it will get the data, okay, because we have already created one method to get the data from this 3 bucket, okay? Then a zip file name, okay, your data name you need to provide. Then data ingestion artifacts directory you need to provide, like after downloading the data, where it will store, okay? So every path actually you need to define here, okay? Then see, whenever you will start the data ingestion, it will get the data from this gcloud storage, okay? Then it will unzip the data, okay, because it would be first of all zip file, then it will unzip the data. So you will have 2 files called imbalanced data file and raw file, okay? I think I already showed you the data. Then what it will do, it will keep inside the artifacts, and it will return the data file path, like this file path and this file path, okay? So that I can access this path, and I can pass this path to my second component, so the second component access, okay, this to file, okay? Then I will return the artifacts itself. So let's create this thing, okay, using code. So first of all, what I will do, I will come here to the component. So here I have a file called data ingestion, okay? I will open this one. So here, first of all, I just need to import some of the libraries. So guys, first of all, I will be importing some of the libraries. So guys, here if you see, I'm importing this OS library, okay? Then this zip file, because I just need this zip file to unzip my, like you can say zip file, okay? Then logging I'm importing, so from head. So this is your root folder head. So here I have a logger folder. So here if you see, I have a logger folder. Inside I have my logging. Sorry, not this one, yeah, logging. And I'm just importing logging, okay? So if you just import logging, so it will import your logging, okay? Similar wise, head exception, okay, you have the exception, and inside exception you have this custom exception class, okay? I'm importing this one, okay? Then I'm also importing gcloud sensor from this cloud sensor, this class, okay? So that's actually I'm importing all, okay? Now here, 2 things I think you have already observed. I haven't imported this I haven't written this data ingestion configuration and data ingestion artifacts, okay? As I already told you, we need to create these are the things also. So where I can create this one, so for this, let me remove these are the thing. So for this, there is a folder I have created called entity. Just open the entity, and here you have artifacts entity and configuration entity. So first of all, let's create our configuration entity, okay? So here, first of all, let's create our configuration entity. So first of all, here I will import some of the libraries, okay? Like data class, I'm importing data class. I will tell you what is data class. And I'm also importing from head, there is a constant folder I have created. Inside that I'm importing everything, okay? So there is a constructor, but here I haven't written anything, okay? So first of all, I need to write something here, okay? So what I need to write, let me tell you before, let me define my data class, okay? So first of all, I need to define data class related for my data ingestion components, okay? So guys, this is the data ingestion config data class. So here basically see, data class is nothing but it's like a class only, but it's not an actual class, okay? If you are just calling this decorator, okay, of this data class, so actually in this class, what are the variable you will define, okay? Everything you can access from the other file itself, okay? And here if you see, this is my class variable name, like bucket name. See, all the variable name I'm defining, and here I'm just keeping the value, okay? Keeping the value, but this is so there actually I haven't directly defined the value, okay? So this value actually I'm reading from my constant, okay? So there is a constant folder, so here in it, okay? So from here itself I'll be reading, okay? Now let me do it. First of all, let me define some of the common constant, okay? So these are the common constant actually you need. So here if you see, here I am defining my bucket name. So where you will get the bucket name, so if you come here, so if I go back, yeah, sorry, I think it was right. Yeah, so this is my bucket name, hate speech, okay? So that's why I have defined hate speech here, okay? And what is my data zip file name? If you click on the bucket, So it was a dataset.zip file. Okay, so that's why I'm writing here. Okay, so with respect to your name, you also need to provide the same thing. Okay, then here these are the things, just keep it as common. Okay, because we need it later on. Okay, now let's define our data ingestion related constant. So these are my data ingestion related constants. So basically, if you see data ingestion artifacts directory, so it will create a folder called artifacts. Inside that, it will create a folder called data ingestion artifacts. Okay, inside that, it will download this imbalanced data.csv and raw.csv. Okay, now if you come here to your entity, now you can see every folder would, every file would be accessible. Okay, every variable would be accessible because I am reading from my constant itself. Okay, that's actually, instead of hard coding the value, I'm just taking as a variable. Okay, so that, see, in future if I want to add something, I will add here. Okay, and it will reflect here. Okay, I don't need to change the code. Okay, internal code. So that's why I'm keeping it everything like modular approach. Okay, so that my our code maintain should be like very easy. Okay, so that's why. So yes guys, the configuration we have already defined. Now what I need to do, I need to also define the artifacts entity. So for that, I will open this artifacts entity. So similar wise, I will also define the artifacts entity. I will create one data class, and I will create one class called data ingestion artifacts, and inside that imbalanced data file path. Okay, raw file path, which is nothing but this two path I am just defining, and it should be string. Okay, that's why I'm giving it as string. Okay, so this path actually it will return. Now yeah, so these are the thing is done. Now if I open my data ingestion, now if you press Ctrl and right click, okay, see, it is accessible. Okay, so now what I will do, I will create my data ingestion class first of all. So this is the data ingestion class, and here I am defining my data ingestion configuration. Okay, this class. Okay, and also defining my gcloud sensor. Now the first method I am going to define, which will actually get the data from the gcloud. Okay, so this is the method. So it will actually download the data from the gcloud. Okay, see here I'm using gcloud since folder from gcloud. Okay, and here I'm giving the bucket name, zip file, file path, and where I just need to download the data. Okay, that's it. Now after that, what it will do, it will also unzip the data. Okay, so for that I have again prepared one method called unzip and clean the data. Okay, so it will unzip the data. Okay, after downloading the data, and it will like save inside a folder. Okay, now to execute this two method, I just need to create one final method called initiate data ingestion. So this is the method, this is the final method. Okay, so here I have defined a docker string also, initiate data ingestion. So I will call this initiate data ingestion from my pipeline itself. Okay, I don't need to call this one by one. So see, this two method I'm calling inside that. So first of all, see, I'm getting the data from the gcloud, so this method I'm calling inside this one, and after that, whenever it will get the data, so again I'm calling the unzip. Okay, unzip method. Then once it is done, I'm returning this two path. I think as you remember, this imbalanced data file path and raw data file path, this two file path I'm just like returning. Okay, after that I'm returning also my artifacts. That's it. Okay, so this is my data ingestion related code. That's it. Okay, now if you just go with the code a little bit carefully, okay, we'll get it. Now what I will do, to test this one, I also need to define my pipeline. So here I have created one folder called pipeline. So here I have train pipeline. Okay, so let's open this one. So first of all, let's import some of the like default libraries, which is nothing but logging and your custom exception. Also, let's import our data ingestion class we have just defined. Okay, so from head components data ingestion, head components data ingestion. Okay, import this data ingestion class. Okay, this data ingestion class. Then with that, I also need to import data ingestion configuration from the config entity. So that's how actually you can import config. And also I also need to import my artifacts. Okay, from the artifacts entity. So head entity, artifacts entity, head entity, artifacts entity. Okay, import data ingestion artifacts. Okay, so these are the thing I need. Now I will define my final training pipeline class. Okay, so here I will initialize my data ingestion configuration. Then with that, yeah, I think it's done. Now let's create our final data ingestion like start data ingestion method, because it will start your data ingestion part. Okay, so that's actually you can define. So basically, if you call this method, what it will do, it will initialize your data ingestion, this class, and in this class I have something called initiate data ingestion. If you see, so here if you see, I have something called initiate data ingestion. Okay, this method, because this is my final method. If I run this method, so it will execute all of the method. Okay, so that's why I'm defining this data ingestion class and I'm calling this method. Okay, and it will start and it will log all the information, and if some exception happen, okay, it will also raise the exception. Okay, so that's why we have prepared our logging and exception. Now to run this one, okay, you again need to create one final class called run pipeline. So I'll create the method called run pipeline. Okay, inside run pipeline I will call this one, your start data ingestion, this method. Okay, now let's also complete our exception block. Okay, so yes guys, I think everything is prepared, but before that let's also complete our logging, because it will start the logging, and once it is done it will also return the logging. Okay, like exited from the run pipeline itself. Okay, I think it should be inside the try. Yeah, so yes guys, I think it's done. Now let's execute and see whether our code is working or not, whether it is able to ingest the data, okay, in our local or not from the G Cloud itself. So for this I will open my terminal. Make sure you have activated your environment. Okay, so let's clear and I will just run Python. Okay, before that what I need to do, I need to also prepare my app. Okay, app.py. So I'll open the app.py. Here I just need to also mention my app.py. So first of all, what I need to do, I will call my pipeline. Okay, from the training pipeline itself, like from hit, then there is a pipeline folder. Okay, here training pipeline. Okay, then I'm importing this training pipeline class, this class. Okay, and from this class itself I'll call this method run pipeline. So let's open. I think I haven't saved this one. Yeah, so now first of all I will initialize my train pipeline class. Okay, then I will call this run pipeline method, import train pipeline. Yeah, now it's done. Now once it will complete the execution, I will print one message like successfully, okay, executed pipeline. Okay, so now let's test it. So I will open my terminal and I'll just write python app.py. So guys, it will take some time because it will download the data, okay, from the G Cloud itself. See, it's downloading the data from this bucket itself. Okay, see, it's done. Now if you see, there is a folder has been created called artifacts. Now if you open the artifacts, again inside artifacts it has created one timestamp folder. Okay, the current timestamp folder, inside that it has created data ingestion artifacts. And guys, if you see, it has downloaded this data.zip, and also it has unzip the data, imbalanced underscore okay, data csv and raw data csv. Okay, that means it is running successfully. Now in our second components, which is nothing but data transformation, okay, we'll get the data from here and we'll apply the transformation. Okay, so yes guys, this is all about from this video. So we have like completed this test. So now what I can do, I can also commit the code, but before that let's add these artifacts inside my git ignore, because it will also push these are the data. Okay, but I don't need, so I'll ignore this one. So I'll come here and here I will just write artifacts. Okay, so if you just write any folder name, it will actually ignore that folder. Okay, it won't be push anything from the folder itself. Let's save it. Now if you see, there is no data. Okay, so now let's commit the changes. So I'll write git add dot, then git commit hyphen m data ingestion added, then git push origin main. Sorry, origin spelling is not correct. Origin main. Okay, so yeah, it has pushed the code. Okay, so yes, so in this video what we are gonna do, we are gonna write our data transformation component. Okay, and in this data transformation component we'll be doing the same thing as we did in our notebook. So what we'll do, we will handling the imbalance data set the way we are handling in the Jupyter notebook. Okay, I will be just copy pasting the same code. then we'll be also cleaning the data. Okay, after that we'll be like returning one final CSV file. Okay, so for this actually I will open this data transformation .py. So first of all, here I just need to import some of the libraries. So these are the libraries are needed. So here I'm using NLTK also, because I think you remember as I was doing some stop word removal. Okay, then I was applying some of the, you can say, steaming technique and all. Okay, so that's why I need this NLTK. And I'm also importing trend test split, because I will be also doing the trend test split, okay, of my data. Then this is the custom exception, and this is the transformation configuration. This file, this configuration we haven't created. Okay, we need to create this configuration, and this is the data ingestion artifacts. Okay, so this data ingestion artifacts we have already created. Okay, why? Because it will return me the path, like where my data is present right now. Okay, this path actually it will return, so that's why we have saved this path, right? So that's why actually we are also importing, because I need this path inside my data transformation component. Okay, then I also need data transformation artifacts. Okay, so if I show you this diagram again, so guys, this is the data transformation related component. Okay, so here it will take some of the configuration. These are the configuration it will take, and it will also take your data ingestion related artifacts. Okay, then it will start the data transformation. So what it will do, it will like handle the imbalanced data, it will do the cleaning, it will do the raw data cleaning, it will concatenate the data together. Okay, it will do some pre-processing or cleaning, like I'll be doing a regular expression to remove the HTML tags and all. Then after that it will save one like data frame, okay, in my artifacts folder. Okay, and then I will return this folder file path. Okay, so this is what actually we're gonna do. So let's do it. So first of all, here I just need to create this data transformation configs and data transformation artifacts, these two things. Okay, so for this I'll go to my config entity. So here first of all I'll be creating my data transformation related configuration. So guys, these are my data transformation related configuration, as you can see here. Okay, so these are the class variable I have defined, but this value actually I haven't hard coded, so I will be reading from my constant. Okay, so let's also initialize these are the variable. Okay, so for this what I will do, I will open my constant. Okay, this constant, this init.py just open. So this init.py just open, and here let's mention our data transformation related constant. So these are the data transformation related constant. Okay, I think, okay, yeah. So if you just see it carefully, okay, I will like get it, like what are the things I'm doing here. So basically here I'm taking data transformation relation artifacts directory name. So basically it will create one folder called data transformation artifacts. Inside that it will transform the data, it will save this final.csv. Okay, then this is my id, this is my axis. Okay, which axis I want to apply, this is the implicit is equal to cc, this is the default arguments. Okay, I'm also initializing here. Okay, instead of hard coding those value. And what are the columns actually I was dropping, I think you remember in the notebook. Okay, you just open the notebook and see these are the column actually I also need to drop, so that's why I have mentioned here. Okay, so yes guys, this is all about. Now what I will do, I will come back to my data transformation. Now it should be accessible. Now let's define this data transformation artifacts as well. So I'll open the artifacts file, and here let's mention these artifacts. So here basically I will just only return this transformation data file path, that's it. Now it is done. Okay, now actually I will define the class of my data transformation. So this is the class of my data transformation. So here if you see, I'm initializing my data transformation configuration and data transformation artifacts. Okay, then I'm initializing inside the class. Then so the first method actually I'm going to write, which is nothing but your imbalance data cleaning. Okay, so basically it will load the data, it will drop those values. Okay, and it will like return those like after cleaning it will return those imbalanced data. Okay, the same way we are doing in our notebook. Okay, you just refer the notebook, you will get it. So now here the second method I'm going to apply, which is nothing but raw data cleaning. Okay, so here basically if you see, I'm cleaning my raw data. Okay, so there were some issue with my raw data, so this kinds of cleaning I'm doing here. Okay, now once raw data cleaning also done, so what I need to do, I need to concat those two data frame together. Okay, so this is the concatenation function. So it will concat these two data, your imbalance data and your raw data. Okay, then after that I just need to apply this cleaning operation on my raw data. Okay, on this df. So concat data cleaning. Okay, So it will like do the streaming, stop word removal, then your regular expression, everything it will apply. Okay, and once it is done everything, so it will return your actual data. Okay, so after getting that data, I also need to save those data. Okay, so this is my final function, initiate data transformation. So inside that, if you see, I'm calling all those methods. Okay, imbalance, data cleaning, then raw data cleaning, concatenate data frame, concatenate data cleaning. Okay, everything I'm calling. After that, once it is returning the data, I'm saving. Okay, I'm saving to CSV. Okay, in my artifacts folder. Once everything is done, I'm returning this transformation artifacts, which is nothing but transformation file path. Okay, so that's it. Now to execute this one, you also need to initialize inside your trend pipeline. So let's also initialize here. So first of all, you need to import your data transformation okay, data transformation class from this data components. Okay, from data transformation components from here. Okay, this class I'm importing. Okay, so once it is done, I also need to import my data transformation configuration. So here let's import. I'll just give comma and paste. And similar wise, I will also import my data transformation artifacts. Okay, so once it is done, I will also initialize my configuration inside the class. So here I just need to also initialize the configuration. Okay, once it is done, now I will create one method called start data transformation after this data ingestion. Okay, start data transformation, it will basically your initialize your data transformation class. Okay, and it will call that method initiate data transformation, which is nothing but this one, our final method we have created. Okay, so once it is done, then I will also mention inside my run pipeline after data ingestion, I will initialize my data transformation pipeline. Okay, so now it is done. Now let's execute the code and see like whether it is working or not. Okay, so I'll open my terminal and here let's write python app.py. Okay guys, so it is giving error because we haven't activated the environment. So let's activate. So conda activate. I think it was hit. Okay, now if I execute the command python app.py, it should work. So guys, it is getting the data. So guys, see, it has run successfully. Okay, so ignore this one. This is not a error. Okay, this is a warning. So it has run successfully. Now if I open this folder, now here if you see, first of all, it has created data ingestion artifacts, which is nothing but I already discussed. It will download your data and it will unzip. And after that, it will get those unzip data. Okay, and it will do this pre-processing. Okay, like your transformation, and it will save this final.csv. Okay, now if I open this, so this is my final.csv. Okay, so now this data actually I'll be using for my model training purpose. Okay, so yes guys, this is all about from this video. So as we already completed our data transformation stage. Okay, so in our next video, what I'm gonna do, I'm gonna write our this one our model trainer part. Okay, so in this video, let's start with our model trainer. So here I have already prepared my data, which is nothing but final.csv. So this data set I will be picking up. Okay, and I will be like doing the model training operation. So let's open this model trainer. So first of all, let's me remove. So in model trainer, let's import some of the libraries first of all. So guys, the same way actually I'll be following. Okay, the way actually I'm following till now. So here I'm importing some necessary libraries, and we haven't created the model architecture, so we'll be creating the model architecture. Okay, inside the ML folder. Then model training configuration need to create, and model trainer artifacts you need to create, and this transformation artifacts it is already created. Okay, so first of all, let's create the model architecture. So here there is a folder I have created called ML. So I will expand, and there is a file called model.py. Okay, so I'll open this one, and here I will be writing my model configuration. So first of all, let me import some of the libraries. Okay, see guys, so I'm following the same model architecture. So the model architecture I defined in my notebook. Okay, this is the same model architecture. So here, first of all, I need to write my model trainer related configuration. So I'll open this config entity. Let's mention this model trainer configuration here. Okay, so these are my model trainer related configuration. If I open my flowchart, So guys, as you can see here, these are my configuration I need, and I also need my data transformation artifacts, and I will start the model training. It will like do the splitting operation, it will do the tokenizer, it will do the model.fit, and it will return the your model path and your x data path and y data path. Okay, so for that actually I have prepared this configuration class. Okay, it will return everything. Now inside this variable I just need to initialize in my constant. So I'll open my constant file, and here let's mention all my model trainer related constant. So these are my model trainer related constant. Okay, as you can see here, it will create one folder called model trainer artifacts. Inside that it will save your model and your data. Okay, and this is the random state, epoch size, batch size. Here you just you can mention everything. Okay, so I will open my model.py. Now it should be accessible. Yes. Now first of all, what I'm gonna do, first of all, let's initialize one class called model architecture. Okay, so I won't be writing anything inside the constructor, that's why I'm doing pass. And here I will define one model. So this is a simple model, guys. I was just defining in my notebook, as you can see here. So it's just one LSTM based model. Okay, so max word, I think this is, we haven't defined. Let's define also. So I will open my constant again, and here let's mention model architecture related constant. Okay, so this is the model architecture related constant. Here I am defining max words, max length. Okay, accuracy, activation, and your loss. Okay, so and how I'm importing head constant, import everything. Okay, now everything is accessible. Okay, so this is my model architecture. So now what I will do, I will come back to my model configuration. I think everything is fine. Now let's write our this one. I will open my model trainer. Let's write this model trainer artifacts. So I'll open my artifacts entity. So these are the artifacts I need. Our model file path, x data and y data. Okay, that's it. Now let's write our model trainer class. So guys, here if you see, I'm just mimicking this notebook, but here actually I'm organizing the code, okay, in a different folder structure, so that actually whenever, if you want to change something in your code, okay, you don't have to change anything inside the code. So what you can do, you can open the constant, you can open the config, and there actually you can make the changes and it will reflect every file. Okay, so that's why I'm making organize of your code. Okay, otherwise this code is same. Okay, that we did in our notebook. Okay, now this is my model trainer class, and here I'm initializing my model data transformation artifacts and my model trainer configuration. Okay, now first of all I just need to apply train test split, because before training the model I need to apply train test split. Okay, so this is the method, so it will do the train test split of your data. After that, I think you remember, if you are working with NLP, so you need to apply also tokenizer. Okay, so I was also doing inside the notebook tokenizer. It will return your numerical data. Okay, then I will initialize one final method called initiate model trainer. Let me show you this method. So this is nothing. So here what I'm doing sequence by sequence everything. So first of all I'm logging. Okay, then after that I'm getting my model architecture. First of all I'm splitting my data, then I'm getting my model architecture, initializing my model architecture, then I'm getting this model architecture. So it will return my model. Then here what I'm doing, I'm applying my tokenizer. After that I'm fitting my data with my model. Okay, after that I'm dumping my tokenizer. Okay, then I'm also saving the model. I'm also saving my x data and y data. Okay, then if everything is done, then I'm also returning this model trainer artifacts. Okay, as you can see here, these are the artifacts we are returning. Okay, so now let's test it. So for this I will open my model train pipeline. Okay, so here I need to mention, first of all, let's import my model trainer. Similar wise, I will import my model trainer configuration, then model trainer artifact as well. Okay, then I will initialize my model trainer configuration here. Now let's start. Now let's write the model trainer final class here. Start model trainer. Okay, it will start the model trainer, it will initialize that class, and it will call it initiate model trainer, which is nothing but this one. Okay, this one. Now after that I will mention inside my run pipeline. Okay, so it will start your model training. But I'm not going to run this code as of now, because before that I also need to create this model evaluation, okay, because I also want to see the metrics and all. Okay, so what I will do, I will also create this model evaluation, okay, this component, then I will execute the project finally. Okay, so I'll open this model evaluation. First of all, let me remove this data ingestion and model trainer. Okay, so let me import some of the libraries. So as you can see, these are the libraries are needed. So here, let's see what are the things are missing. So everything is there. I just need to create model evaluation configuration and these artifacts. Okay, so to create this one, I will open my config entity. Let's mention this model evaluation configuration here. Okay, so these are the my configuration. So if I show you the flowchart again, so I think it should be clear. Model evaluation. Okay, see, I need, these are the configuration. I also need my model trainer artifacts. Okay, data ingestion artifacts as well. Then it will actually, what it will do, actually it will measure your metrics, like your uh, like some of the classification metrics it will measure. Okay, so basically, see why this model evaluation stage is required. So basically what we are gonna do here, so first of all, actually, whenever you will be running this project for the first time, it will train the model and it will push the model to you, to your GCP cloud. Okay, then whenever you will be running for the second time, so what it will do, instead of pushing the current model to the G cloud, okay, first of all it will get the existing model from the G cloud, and it will measure the metrics okay, between your current model and G cloud model. Okay, if your current model is working fine, okay, then your G cloud model, then it will push, otherwise it won't be push. Okay, because see, why, if this model is not performing well, then why I need to push? Okay, I will be keeping my previous model. Okay, so that is the logic actually we are doing here. Okay, and simultaneously we are also calculating the metrics like accuracy metrics and all about. Okay, then it will return one statement called is model accepted or not. Okay, if your existing model is working well, then it will return is model is equal to true, otherwise it will return is model is equal to false. So whenever I will be getting the true, I will push the model. If I'm get the false, okay, I won't be pushing the model. Okay, so this is the logic here I'll be doing here. So let's do it. So I will open my evaluation configuration. So I need to also initialize this constant. So let's open my constant file, and here I will mention my model evaluation related constant. So basically, after calculating all the metrics, it will save it in this loss.csv. Okay, and yeah, so now I will open this evaluation. Now I think everything should be accessible. We haven't created evaluation artifacts, so let me open the artifacts entity. So here let's mention, okay, model evaluation artifacts. Now I think everything should be accessible. Yeah, so now let's initialize our final class of model evaluation. So guys, now let's initialize our final model evaluation class here. So this is the model evaluation class, and inside that I'm initializing this one, model evaluation configuration artifacts and transformation artifacts, and inside that I'm like writing everything inside the class variable. Okay, so once everything is done, so the first method I'm going to write get model from G cloud, because I need to check whether my model is available or not. Okay, in the G cloud, if it is available, then it will get the model. Okay, then it will get the model. After getting the model, it will apply the evaluation. So this is the evaluation method I prepared. Okay, so this is the evaluation. So here basically I'm doing the evaluation on my test data. I'm reading my test data from my like artifacts. Okay, then I'm also loading my tokenizer.pkl. Okay, then here if you see I'm loading my model, then here if you see I'm like doing the loss calculation. Okay, then I'm returning the accuracy. Okay, now I'll be writing one final method called initiate model evaluation. Okay, so this is the final method. Here if you see uh, yeah, so here if you see, this is the logic. So if your best model accuracy is greater than your trained model accuracy, okay, it will return model accepted is equal to true, otherwise it will return false. Okay, then I'm returning the model evaluation artifacts. That's it. Okay, so yes guys, this is the logic. So basically this logic is required for pushing the model to the G cloud. Okay, if your model existing model is performing like good than your G cloud model, then okay. Now let's mention inside our train pipeline. So I'll import my model evaluation. Similar wise, I'll import my model evaluation configuration. Okay, then model evaluation artifacts as well. Then I will initialize my model evaluation configuration inside my class. Okay, then I will write this start model evaluation, start model trainer, start model evaluation. Okay, so it will start your model evaluation. It will initialize this class and it will call this initiate model evaluation. Then I also need to mention inside run pipeline. So here I'll be mentioning my model evaluation, this method. Okay, now guys, everything is fine. Now what I'm gonna do, I'm gonna execute the project and let's see whether it is working or not. Okay, and then after that I will be finishing this model pusher as well. So I'll open my terminal. Let's clear. Let's write python app.py. So guys, it will take some time to train the model. Okay, once it is done, I will come back. So guys, as you can see, our training has started. Okay, so this is the training, it's going on, and this is the loss, and this is the accuracy, and this is my final model, and these are the trainable parameters. Okay, so let's wait, okay, until this training gets over. So guys, as you can see, training is done. It's telling successful. Now if I open this folder, now here if you see, it has created another two more folder called evaluation artifacts. So here if you see, inside evaluation artifacts, it has saved this one, your best model. Why it is saved best model? Because I already have one model in my GCP cloud. Okay, so that's why that model it has downloaded. Okay, and inside model trainer artifacts, as you can see, it has saved your current model, okay, which it has trained right now, and it has also saved the data. Okay, so yes guys, I think it's working fine. Okay, now what I will do in our next video, we'll be writing this one, our model pusher components. Okay, it is very simple. So here basically will be if our evaluation stays returned like is model accepted is equal to true, then we'll push this model. I think I already showed you this inside the train artifacts. This model will push to my G cloud, otherwise we won't be pushing. Okay, so these are the package I need, and I need to create this model pusher configuration and model pusher artifacts. Okay, so for this I will open this config entity. So here I will be writing this model pusher related configuration. So these are the configuration are needed, and it is already defined. Okay, I don't need to define. So here bucket name, model name, and your train model file path. That's it. Now similar wise, I will also define this model pusher artifact. So I'll open this artifacts entity. So here let's mention model pusher artifacts. Okay, so now here let's initialize the class. So this is my model pusher class. So here I am calling this model pusher configuration, and this Z cloud sensor. Okay, so the first and final method actually I'm going to write here, which is nothing but initiate model pusher. Okay, so here if you see, what it will do, it will first of all log the information it has started the model pusher, then it will call this since folder to G cloud. Okay, so basically it will come here, it will take the model, okay, and it will push the model to your G cloud. Okay, and here I've given the bucket type, like which bucket it will push the model and everything. So here if you see, here this is my bucket name, head speech bucket. So inside that bucket it will keep the model. Okay, so it's done. Now once everything is done, so it will return the artifacts like model pusher, this bucket name. Okay, so now let's save it, and I'll write inside my training pipeline as well. So here let's import my model pusher. Okay, now here I also need to write my model pusher configs. I need to import, and model evaluation model pusher artifacts as well at the last. Okay, then I will also initialize here model pusher configuration. Then I will write one final method called start model pusher. Okay, everything would be sequence by sequence. After evaluation, I will write this one because it's a pipeline. Okay, so it will run sequence by sequence. Okay, after the ingestion, it will run the transformation, then it will trainer, it will do the evaluation, and it will start the model pushing. Okay, so here it will push the model. Here I'm calling this initiate model pusher. Now here I just need to mention inside my run pipeline. So for this, I will write one if else condition. I think you remember. Okay, so what I'm doing, So here one if this condition I'm writing, so I'm telling if not model evaluation, this parameter, if it is false, okay, if it is false, so what I'm doing, I'm trained model is better than your best model, okay. So that means I don't want to push my model here, okay, I'm raising the exception. And if it is not, then I will call my model pusher, okay, model pusher, that's it. So this is the check I just need to do, and once everything is done, yeah, I think it's ready to go. Now if you execute this one, your python app.py again, okay, python app.py again. So again it will do the ingest, again it will run from the first itself. So it will ingest the data, it will transform, it will evaluation, it will train the model, okay, then it will push the model, okay, to the G cloud if your current model is like better than your previous model. But for me, I already have one model presented in my G cloud, okay, and this model I have trained with multiple epochs, okay, so this is the best model. But here if you see inside my constant, here I kept my epochs is equal to 2. So now okay, every time you like train the model, it would be like very poor model. So if you want good models, so just increase the epoch size, okay. So that's why I will be stopping the execution, because I already trained the model, okay, and it will push the model. I already checked, so you can check from your side, okay, everything is working fine. So yes guys, this is all about from this video. So as of now we have completed our training pipeline, okay, but we haven't completed the prediction pipeline. So in our next video, what we are gonna do, we are gonna write our prediction pipeline, and we'll be also making one API, okay, using FastAPI, so that actually user can like put the data, okay, and they can get the prediction, okay. So in this video we'll be creating our prediction pipeline, and we'll be also design one like you can say app, one API, okay, so that actually whenever we'll be running our app.py, it will give me one UI, okay, so that I can at least give some data, okay, and I can at least do some prediction. Even I will also create one training route, okay, so if you just hit the training route, it will start the training. So for this, what I will do, there is a file I have created inside pipeline called prediction pipeline.py, okay, I will open this one. So first of all, you need to import some of the libraries, and this is the same thing, okay, as of now we have created. And after that, let's create our final prediction class, okay. So this is my final prediction class. So here basically if you see, I'm creating one prediction class. Inside that I'm like initializing all the class variable, okay, whatever variable I need, okay. And why I'm giving this name, because inside artifacts, okay, it will create one like a folder called predict model. Inside that actually it will save the model after getting the model from the G cloud itself, okay. See, what is the prediction pipeline? Prediction pipeline means suppose whenever user will hit the prediction, okay, so first of all it will check in the folder whether this model is available or not, okay. If it is not available, what it will do, it will go to so it will go to your GCP cloud, okay, and it will download the model in that folder, and then it will do the prediction, okay. So that's why. So the first method I'm going to write here, which is nothing but get model from G cloud, okay. So this is the method, it will get the model from the G cloud itself, okay, and this is the same method I'm using, okay, if you see in our previous code also. Then I will write this final prediction code, okay. So this is the predict function. So this is the same function we did in our notebook. Here if you see, so basically here I will load my model, okay. After loading my model, I will load my tokenizer, okay. After that, what I will do, I will do the prediction. After doing the prediction, here I'm like measuring the probability, okay. After that, here I'm just returning like it is a head speech or like no head speech, okay. So that's it. Now you need to create another final pipeline called run pipeline, okay, to execute these two methods. So let's initialize it here. So run pipeline. So here basically if you see, I'm getting the model from the G cloud, then I'm doing the prediction, then I'm returning the predicted text, okay. Now once it is done, so our prediction pipeline is ready. Now let's create this app.py, okay. Let's create the FastAPI API. So for this I will remove these other thing. So first of all here, let's do some import, okay. So these are the libraries are needed. Then first of all you need to what you need to do, you need to initialize your FastAPI, okay. So that's actually you can initialize your FastAPI, okay. Then you need two route, one is like training route, okay, because I want to create two route. So this is my training route. So if it gets last train, that means it will start the training. So it will first of all initialize your train pipeline objects, then it will run this run pipeline, okay, as we did before. After that it will return the response, okay, and if some error is happen, so it will return the error also. Now similar wise I need prediction route. So this is the prediction route. So same way I'm initializing my prediction class and I'm calling this run pipeline, okay, and by default I'm passing one text. If you see what is machine learning, okay, if you are not passing anything, I'm by default I'm passing one text here, okay. Then I need to also start this app. So for this is the code you need to write, okay. So if we can't run, so here I have mentioned app host and app port. So where I got this app host and app post, if you just click here, so I have mentioned inside this constant, okay. So here if you see, this is my app host and this is the app port. So you can also change this port number, okay, as per your requirement. Now I think it's done. So let's execute and see whether it's working or not, okay. So I'll open my terminal. So let's activate the environment. So conda activate it, then python app.py. So guys, application is running. Now let's go to our browser. Here let's search localhost 8080. Okay, so this is the application is running. Now here if you see, there is two route. One is like training and prediction. So if you just click here and try out, and if you just click on execute, okay, so it will start the training, okay. I'm not going to train because it will take time. I have already tested, it's working. So let's show you the prediction. So come here, the predict. Here you can just expand, okay, click on try out, and here you just paste your text, okay. So let me take some data. So what I will do, I will open my project folder. I think here I have my data, raw data, imbalance data. Okay, let's take our final data, which is inside transformation final. Yeah, so here let's take this text. Okay, now let's paste it here. Now let's execute. See guys, this model is not presented in my local. So first of all, it is downloading the data from the G Cloud. Okay, then once it is downloaded, it will do the prediction. Now let's wait. So guys, as you can see, prediction is done and it is giving the response, which is nothing but no hit. But although this text is hit, because why it's giving the wrong prediction, because I told you I trained this model like very less epochs, okay. So at least you need to go for 200 epochs, then I think you will get a good model, okay. But our pipeline is working perfectly, okay, no issue with that. So we have successfully completed this project, okay. So now what I need to do, I need to dockerize this entire code, and from the next video itself, what I will do, we'll also learn like how we can deploy this project, okay. So thank you so much for watching this video. But before that, what I will do, we haven't committed the changes as of now, so let's also commit. So let's stop the execution. I'll just write git add git commit hyphen m edit app ey. Now let's do git push origin main. Okay guys, it's done. So now let's create the Docker file in our next video. Thank you so much. So first of all, let's like initialize some of the thing inside Docker ignore. So here if you see, I have already written, these are the, like you can say files and folder, because see, whenever you build Docker image, okay, so these are the thing is not required. Okay, so that's why I'm ignoring this thing. So I'll provide this one. So okay, you just use my one. Okay, you don't have to write anything here. Now let's open this Docker file. Okay, so now here I already prepared some of the Docker commands. Okay, you can run. So the first one is you need to select one image. Okay, so this is the image I'm using. Then you need to run two more commands. So basically what it will do, it will create one folder called head. Okay, inside head it will copy all of your source code, okay, inside this folder. Then after that it will install some of the utility libraries, okay, like it will do apt get update, okay, these are the thing. Then it will also install some of the additional package. So these are the packages are needed. Okay, then we'll also install our requirement.txt. Okay, after installing everything, we'll also do the requirement.txt. We'll also install our setup.py. Then finally we'll run our app.py. So this is the command. Okay, so this is a simple Docker file I have prepared. So just try to use this Docker file. Okay, it will work fine. So yes guys, this is all about the Docker. Now what you can do, this project is ready to deploy. Okay, so from our next video itself, okay, we'll deploy the project. Thank you so much.